Yeah, hello everyone. So let's discuss today um, about the basic concept of machine learning and overview. So, what is machine learning, right? So, machine learning is. I hope everybody is able to see me, right? Now, yeah. So we can try to understand what is machine learning. So, machine learning is nothing but the part of artificial intelligence, right? That empower the computer to learn from data without speed programming. Also, we can say machine learning algorithm analyze the data, identify the patterns, and make the predictions or decision based on those patterns. The power of machine learning lies in its ability to adapt and improve over time, becoming increasingly accurate and efficient as it encounters more data. So basically, like you can say, we have the hidden patterns, we have the hidden data, we want to understand the trends between the data. So what are the types of machine learning? So types of machine learning is basically like supervised machine learning, unsupervised machine learning, you can say. Reinforcement learning, semi-supervised machine learning is there. Basically, supervised learning is nothing but the data-driven part. Like you have the data trends and label data you have. You want to better find out the like scene data, right? Teaching a student with a textbook and exercise where the answers are provided for the student to learn from, right? And like unsupervised learning, explore unable data to discover hidden patterns and structure. Imaging a detective trying to piece together a case by analyzing clues without a suspect in mind. This is similar to how unsupervised learning method works. So semi-supervised learning combines the benefit of both supervised and unsupervised machine learning. Supervised by using a mix of label and data, basically label data, very less, and then we have this large unlabeled data, and on basis of this very few label data, we try to train the unlabeled data on behalf of this few label data, and then train accordingly, right? So the approach allow for each efficient learning with limited data, like learning a language by reading a textbook, right, and watching a movie, right? So it is like you have a limited knowledge, but still you are seeing the uh, when you're reading the textbook and you will re-watch a movie, then you may have the better idea about this, right? In prospect learning about the training an agent to learn through trial and errors, right? Like agents receive the rewards for desirable action penalties for undesirable ones. Learning optimized strategy, kind of things we can say, right? Supervised learning, like what are the like process? First of all, you will have to collect the data. Initial step gathering the relevant data and preparing it for analysis, right? May include cleaning, transformations, transforming. You can do. You can split the data into training and testing set. And then once this task is done, then you can go ahead with. Okay. So model selection and training, choose an appropriate element such as linear regression, logistic regression, decision tree, and train it on the prepared data to learn the relationship between the feature and target variables, right? Model evaluation and tuning. So basically, you can like check the accuracy, as I told you that like we have to need to understand the once you apply the model training or model selection, you need to just check the evaluations, right? So for that you can like check the metrics like accuracy, precision, recall upon score, fine tune the model parameters to optimize its performance on the testing set. So basically you do deployment and deploy the trained model for real world application and continuously monitoring its performance. Update the model with the new data to maintain its accuracy and adapt to change patterns, right? So that's what linearization, same thing. Define the problem and find the target variable and feature. Collect the prepare the data, including cleaning and formatting and splitting into training and testing. Right. So first of all, you define the problem, identify the target variable and feature. That's your first task, right? You need to understand, right? And then you train the linearization model on the training data to learn the relationship between the feature and the targets, right? Evaluate the model's performance on the testing data using the metrics like MSE, mean squared error, or R squared. Fine tune the model parameters if required to improve its performance, right? Deploy the model for a prediction on new data. Monitor the model performance over time and update it with the new needed. Predicted house prices, estimating sales revenue. These are the 3 to 4 real life of can try to understand. Unsupervised machine learning, same patterns. Process begins with gathering and cleaning data similar to supervised learning. However, the variable meaning there are no predefined target variable, right? So you don't have any predefined target variable. That means you are not going to break into testing and training here, right? So, but again, like you need to understand the feature. Choose a unsupervised machine learning, like K means clustering principal component or hierarchical clustering. Train the model on the prepared data, right, to identify pattern structure within the data. Interpret the result of the model to gain insight about the structure within the data. Visualize this pattern using scatter plot, standard, or other regression techniques, right? Applications and future further analysis. Apply the insight gained from to real world problem. For example, use customer segmentation to train market campaign or identify anomalies in sensor data. For there are a number of examples that basically we do the grouping, like basically do the customer segmentation, basically do the grouping. With the help of that, we can do it. Go ahead. Initializations, we can, like in k-means clustering, first of all, you choose a random grouping, like a k initial cluster centroid, where k is the design number of cluster you can choose. This centroids represent the initial center of each cluster, right? So assign each data point to the nearest cluster centroid based on the distance of the this forms initial clustering around the centers. And then it will classify the cluster centroid based on the means of all data points, right? Assigns to each cluster. This moves to the centroid to the center of the respective cluster, right? Repeat the assignment and update the step until the cluster centroid no longer change significantly. This signifies convergence and formation of the stable clusters, right? Centroid no longer changes significantly. So basically, the the centroid value should not change. Cluster centroid no longer changes significantly. So that time we can apply those things. Like customer segmentation, group customers into distinct segment based on their purchasing behavior, demographic, or other relevant characteristics. They allow for targeted market campaign and personalized customer experience. Anomaly detections identify unusual patterns or class in the data that it deviate from the norm side. Yeah, this can be used for fraud detection, network security, or predictive maintenance. Data compression due to dimension of the data while preserving information. This is useful for storage efficiency and faster data processing. Okay, so like self-training, unsupervised learning bridge the gap between labeled data. So train a model on a labeled data, then use it to predict models level for unlabeled data, right? Like can significantly improve model performance with limited data. Generative model, like use generative model like VAE or GAN, unlabeled data. Explain the training set and improve the model accuracy. Pro training, right, can generate statistic and divergence data, and here like you can say robust to noisy or incomplete data can improve the model accuracy, right? What is the reinforcement learning? Basically reinforcement learning is like learning through interaction and feedback, like robotics, game playing, finance. Train the robot to perform tasks in complex environments such as navigating obstacles, guessing objects, or assembling products through trial and error with rewards and penalties. Game playing, we can say develop AI agent that can play a game like chess, Go, or video games at superhuman level by learning optimal strategy through interaction with the game. Rewards for winning and penalties for losing. You can say finance one is what optimizing investment strategy by training AI agents to make buy or sales decision based on the market data, news event, and other relevant factors, receiving rewards for profitable trades and penalties for losers. That's all. So I think everybody is getting this point, right? So that's a very great deal here. Thank you very much.